What if I told you there's a whole city, like a bustling, microscopic city living inside the phone you're holding right now? Not just circuits and wires, but this incredible, complex metropolis. Well, today we're going to take a tour of that world. We are going to explore the story of the Silicon City. And that idea? That's going to be our key for this whole thing. We're not just talking about some abstract tech concept. We're talking about a metropolis, engineered with just unbelievable precision, all on a little piece of silicone that's smaller than your fingernail. Yep, the very device you're watching this on right now, it's got one. It has superhighways for information, it has skyscrapers for processing and memory, and billions, literally billions, of tiny citizens all working together at the speed of light. Okay, so this whole city planning thing, it has an official name, right? It's called VLSI. That stands for Very Large-Scale Integration. It's basically the art and the science of packing millions and now billions of tiny components onto a single chip to create the powerful electronics that, well, run our entire world. So every city needs citizens, right? Well, in our Silicon City, those citizens are called transistors. Just think of them as the most fundamental building block you can imagine, a tiny, microscopic switch that can be either on or off, a 1 or a 0. Every single calculation, every pixel you see on your screen, it's all thanks to these little citizens working together in perfect harmony. So what does one of these things even look like? Well, at its heart, it's actually kind of simple. It's basically a sandwich. The foundation, or the bottom piece of bread, is a semiconductor, usually silicon. On top of that, you've got a super thin insulating layer and then a metal gate. By zapping a tiny bit of electricity to that gate, you control whether current can flow underneath it. And just like that, you've turned the switch on or off. The whole story of modern tech, it really boils down to the story of these little citizens. And there's this one simple rule that has been driving their world for over half a century, pushing them to get smaller, faster, and more powerful, year after year. And that brings us to the famous Moore's Law. Now, this isn't a law of physics or anything. It was an observation, a prediction really, by Intel's co-founder Gordon Moore. And it became the guiding principle, the city planning rule, for the entire industry. It basically said our silicon cities are going to get twice as dense and way more powerful about every 2 years. And wow, you can really see Moore's Law in action right here. The size of these components has just been in a free fall for decades. I mean, we went from measuring things in microns back in the 70s all the way down to nanometers today. That is so small you could fit millions of them on the head of a pin. These citizens just keep shrinking, letting us pack more and more of them into denser and more powerful cities. Okay, so not all these citizens are created equal. They actually come in 2 main flavors. You've got your enhancement mode transistors, which are like a regular light switch. They're off by default, and you have to give them a go signal, a little bit of voltage, to turn them on. Then you have depletion mode transistors. They're the opposite. They're on by default, kind of like a fire alarm that's always armed, and you need to send a signal to specifically turn them off. You need both to build the really cool, complex circuits. All right, so we've met the city, we've met the citizens, but how in the world do you build something this tiny and this complicated? The process is just a marvel of modern engineering. It's almost like magic. So let's walk through the basic construction plan. So building this city is like the world's most microscopic construction project. First up, you need a foundation, a perfectly pure, clean wafer of silicon. Next, you need the blueprint. Using a crazy process with powerful light, you basically etch the entire city plan onto the surface. After that, you build the framework, adding layers of materials to create the actual gates for all our transistor citizens. Then you carve out the pathways, adding special impurities to create electrical lanes. And to stop any traffic jams, you add insulation, protective layers to keep all the signals from crashing into each other. And finally, the last step, you install the power grid. This is a metal layer that connects all the citizens together and brings the whole city to life. And get this whole process is repeated over and over to build a city with dozens of layers. And when it's all said and done, you get something that looks like this. I mean, just look at it. This is a cross-section showing all the different neighborhoods and the infrastructure of a super advanced chip. It looks impossibly complex, and you have to remember, this is all happening on a scale that is completely invisible to the human eye. It's just mind-boggling, right? And this is the crazy part. Remember where it all started. All of this staggering complexity, everything we just saw, is built from that one simple idea, that tiny, reliable citizen, the transistor. It's the ultimate proof of how simple little building blocks can create something absolutely extraordinary. Now, obviously, these cities don't just spring into existence. There's a whole army of brilliant engineers, the true architects of intelligence, behind every single chip that gets made. So, let's meet the key players. This really does take a massive team effort. You've got the logic builders who design the core functions of the city. Then you've got the design gatekeepers. They're like inspectors, testing the blueprints for any bugs. The silicon sculptors are the ones who turn that blueprint into an actual physical layout. The test strategists build in clever ways to check the city after it's been built. And finally, you have the wave whisperers, who design these super important parts that let our digital city talk to the analog real world. Every single role here is absolutely essential. Okay, so we've seen what they are, how they're built, and who the architects are. But why should you care? Why does any of this matter? Well, the impact of these tiny little metropolises is anything but small. These silicon cities are the silent engines powering our entire modern world. They're the magic that makes your smartphone smarts and your gaming consoles so realistic. They're the brains in your car that keep you safe. They're the power inside the medical devices that save lives. And they're the core of the networks that connect every single one of us. Seriously, look around you. Almost every piece of technology you see is powered by one of these tiny, incredible cities. And really, that kind of sums up the whole spirit of this field, doesn't it? It's a world of constant, relentless innovation, where progress is driven by creativity and unbelievable precision. Every revolutionary new gadget, every single leap forward, it all starts with one brilliant idea for how to build a better city. Because here's the thing, this revolution is nowhere near finished. Our silicon cities are getting more powerful and more efficient every single year. The real story isn't just about how small we can build, it's about how big we can dream. With all this power at our fingertips, the only real question is, what will we build next? The cities of tomorrow are just waiting to be designed.